All right, section 4.2. So we're still solving systems of linear equations in two variables, but now we're using substitution. So the only objective in this section is to solve using substitution. Solve systems, that is. So as promised, I've included the definitions from that last section, all the boxes that we filled in, just to give us a little reminder. So what a system of equation is. Remember, we can have one solution, infinitely many solutions, or no solution. One solution means that the lines are intersecting. Infinitely many means that they are parallel. Or I'm sorry, not parallel, they're the same line. No solution is the parallel. And then our three methods, we looked at graphing, and we are doing substitution today, or in this video. The next video will be elimination. And then remember, dependent equations is what happens when they are parallel. It's how we classify them, as well as classifying systems as consistent or inconsistent. Remember, consistent means that it's one of these two solution types. Inconsistent means that there is no solution. So, flip the page here. You'll notice there's just one problem here, and that's because we're going to go through, there's another example we'll do, but we're going to walk through the steps, and we're going to write out some guideline steps for you to have as reference in your notes. So when you're doing substitution, the first thing you need to do, this is number one, is solve one of the equations for one variable. Now, it doesn't matter which one you solve for. You could pick x, you could pick y. It doesn't matter which equation you choose. You could pick the first one, the second one. It's entirely up to you. So I'm going to pick the first one, and I'm going to solve this for x. So I have 3x equals 2y plus 2, adding that 2y over, divide by 3, and I have x equals 2/3 y plus 2/3. This should be, let's not forget our negative, this should be a negative 2/3. So now once you've done that, the next step is to substitute your variable into the other equation. Meaning the one that you didn't solve. So I solved equation 1, so I'm going to substitute this expression in for x in equation 2. So this is 2 times the quantity, 2/3 y minus 2/3, not equals, and then it's minus 9y equals 10. So this is where it gets its name from, substitution. And it's because x equals this. So now, once you've done that, the third step is to simplify and solve for the other variable. So I'm going to distribute the 2 and get 4/3 y minus 4/3 minus 9y equals 10. Now, I don't particularly want to deal with fractions, so I'm going to multiply the whole equation by 3 to make my life a little bit easier, and get 4y minus 4 minus 27y equals 30. Then I have minus 23y total, minus 4 equals 30, minus 23y equals 34, divide by negative 23, and I have y equals negative 34 over 23. So now that I've solved for the other variable, we use the expression from step 1 to get our last variable. And I'm going to abbreviate as var. So I'm going to take this value and I'm going to plug it in here. So x equals 2/3 times negative 34 over 23 minus 2/3. So I'm going to multiply my fractions here. This is negative 68 over 69 minus 2/3. So I'm going to multiply by 23 on the top and bottom to get a common denominator. And so it's negative 68 minus negative 46 over 69. And when you simplify this all the way down in my nice little calculator, you get negative 38 over 23. And this is what x is. So our solution is negative 38 over 23, comma, negative 34 over 23. Now the last thing that you should do is check your work or check your solution. And this means plugging our point back into our equations. So plugging negative 38 into the first equation, we have 3 times negative 38 over 23 minus 2 times negative 34 over 23. This should equal negative 2. So again, to make my life a little bit easier, I'm going to multiply this whole thing by 23. And that's going to get us 3 times negative 38 minus 2 times negative 34 should equal negative 46. And again, using my calculator, we have negative 76 plus, it's not 76, it's, this is why I use a calculator, not try to do things off the top of my head. It's negative 114 plus 64, which does in fact equal negative 46. At least it does if I multiply 2 times 34 correctly, adding 68. And now I'll leave the last equation, plugging it into the second one, up to you to check, but it will work, and this is indeed our solution. So, a little bit involved. Substitution is usually students' least favorite of the three, even though graphing is the least useful. Substitution requires a lot of work. You have to solve for a variable, plug it in, solve for the next variable, get your solution, and then check it in both equations. So we're going to do one more example together, specifically because a lot of times students look at a problem like this with fractions and go, I don't want to deal with fractions. Well, just like I did in the last section, we can multiply by a common denominator. For this first one, I'm going to multiply by 6. And for the second one, I'm going to multiply by 12. And when we multiply by 6 on this first one, we're going to get negative x plus 3y equals 3. And on the second one, we're going to get 4x minus 2y equals 9. So I can solve this system instead. Now, one thing to note is this doesn't mean that our answer isn't going to have fractions, right? Just look at the last problem if you need any more proof. There's no fractions to speak of here, but our answer were pretty ugly looking fractions. So, we're still using substitution. I've got this equation nearly solved for x already, so I'm just going to finish that up. Adding x and subtracting 3, we get x equals 3y minus 3. Just solving this equation plus x minus 3 to both sides. And then I can plug that in to this equation here, and we have 4 times 3y minus 3 minus 2y equals 9. Distribute my 4, 12y minus 12 minus 2y equals 9. 12y minus 2y is 10y, minus 12 equals 9. Add 12 to both sides, and we have 10y equals 21. Divide by 10, and we get y equals 21 over 10. See what I mean? Fractions galore. And now we're going to take this y and plug it back into our original expression. So x equals 3 times 21 over 10 minus 3. This is 63 over 10 minus 3 over 1 times by 10. So we can subtract them on the top and bottom. 63 minus 30 is 33 over 10. So our solution potentially is 33 over 10, comma 21 over 10. But we're not done. We need to check it back in the original. So we have negative 1/6 times 33 over 10 plus 1/2 times 21 over 10 should equal 1/2. So this is going to be negative 33 over 60 plus 21 over 20. I'm going to times by 3 here. So we have negative 33 over 60 plus, what is that, 63 over 60 should equal 1/2. 63 minus 33 is 30, and 30 over 60 is definitely 1/2. So equation 1 works. Now for equation 2, I'll do that one together with you. 1/3 times times positive 33 over 10 minus 1/6 times 21 over 10 should equal 3 over 4. So this is 11 over 10 simplifying minus, I can cancel a 3 out of these, and this becomes 7 over 20. That should equal 3/4. I'm going to multiply by 2 over here. And we'll have 22 over 20 minus 7 over 20 should equal 3/4. 22 minus 7 is 15 over 20, which does indeed reduce to 3/4. So our answer was correct. So that's substitution. It's a longer process than you may like, but it will get you the right answer. You do have to check your work, though. You must check in your original 2 equations to verify your solution is actually a solution. All right, so the next section will be the last of chapter 4 for us, section 4.3.